Okay, so good morning, everyone. In the last session, we had discussed about the estimating moments of a stream. So basically, calculating the moment of the stream is to measure the distribution of the whole data set, whole incoming data stream. What is the overall distribution of the whole data set? We can calculate the zeroth moment to find out the distinct element in the stream. We can calculate the first moment to find out the length of the stream. We can calculate the second moment, that is also called the surprise number, to find out the skewed distribution of the element in the stream. By calculating the moment, we can find out the uh, set of stream or sample of stream to analyze some particular information, because maybe there are some portion of the stream which is having a more concern compared to the other portion of the stream. So by analyzing the distribution of the element inside the stream, we can find out the desired patterns or desired sequences in the stream. There are various application of the moments frequency moment. For example, we have discussed a few of them here, and apart from them, you can find out the more application in the analyzing the data analytics of a data stream. Now we'll start from the counting oneness in a window. Okay, so suppose we have a data stream and we want to calculate the number of ones within the stream. Here we are assuming that the whole stream is consist of binary stream. So there are only two elements. One is zero, another is one. So we can find out that length of the n. Suppose we have taken a length of a n, and we have declared it as a window, and we have to find out the number of one within that length of the n. So we can take any number of k, which would be less than or equal to n, and we the problem is here to find out the ones in the last k bit. So suppose we have received the 10 bits at the last, then we have to calculate how many ones are in those 10 bits. Suppose we have received the 100 bit in the last data string. So we have to find out the how many number of ones in there in a last 100 bit of system. Now, so for this we need to understand the DGM algorithm. DGM algorithm is given by the organist and Motwani algorithm. It is designed to find the number of ones in a data set. It uses O log n base 2 bits to represent a windows of n bit. It will give us the score of 50% precise answer. So if you are calculating the number of one for data stream, though DGM algorithm is giving a 50% precise answer, it means it will always provide you 50% correct answer, more than 50%. So we are referring a blog written on the medium.com to understand DCM algorithm. So let us open the blog. No. So I will suggest you that you should read the blog, but I will skip the content, introductory part from the blog, and will directly go to the DGIM algorithm. So DGIM algorithm is designed to find the number of ones in a data set. It uses O log n base 2 bit to represent a window of n bit. So if there is an n bit of windows that we are taking to calculate the number of ones, then algorithm will represent all those n bit to the O log n base 2 bits. It will allow to estimate the number of us in the window with error of no more than 50%. So whatever your result is there should not be any error more than 50%. So what the design algorithm do? It will take each bit that has a timestamp. Timestamp is the time on which you have received the that particular bit, and so we'll take that timestamp as a position of the bit. So we can represent the timestamp as a location of the bit. In the first bit has a timestamp one, then the second bit has a timestamp two, and so on. So suppose we have a timestamp n. So we can represent an bit of information here, where every bit of information will be represented by their received timestamp. So here timestamp one means that as per our calculation, we have assumed that whatever the timestamp is the current timestamp, we'll assume it as a one, and the next second bit and so on. After every second, whatever the bit we are receiving, we'll assign it as a incremental timestamp. So by this, we can create this type of data stream. So this is an window length of n data stream, and this is a binary data stream which is representing 1 and 0. Here author has assumed that n equal to 24. That is a window size. So let us explain the algorithm first, then we'll go for the algorithmic steps so that it can be better understandable. So what it done here, it will create a bucket of the bits. The only condition with the bucket is that all the packet size should be power of 2. So whatever the bucket size should be, that should be 2 power 0, 2 power 1, 2 power 2, up to 2 power 10. So whatever the bucket size should be, 2 power 2. So suppose we have created a bucket of size 2 power 2. Now it will come out at the 4. So if we'll take a evaluation of 2 power 2, it will give us a 4. Now we'll count the 4 ones. So we never count the 0. We only count the number of ones. There are 4 ones. 1, 2, 3, 4. So we'll take these bits and will be represented by the bucket size of 2 power 2. Again, we'll all skip all the zeros and we again can create a bucket of ones. So we'll take 1, 1, 2, 3, 4, and we'll create a bucket of 2 power 2, 4, and so on. So you can find out that there are 1, 2, 3, 4, 5 bucket has been created. 2 bucket is of size 2 power 2, and 2 bucket is size of 2 power 1, and 1 bucket is size of 2 power 0. So you can find out that it is representing all the number of ones inside the bucket. So you can create any kind of bucket, but always remember that leftmost bucket should have a higher size compared to the rightmost bucket. So when you go to the rightwards, you have to decrease the bucket size and so. So you have to make sure that this should be inside when you're creating a bucket. Now, what will happen when we receive a new bit? So suppose this is our incoming bit stream that is represented by 0111. So this is our incoming bit stream. Now, when we receive a 0 bit, we do nothing and we'll not going to take any step for that. But when we receive the 1, what we'll do, we'll create a bucket of that particular bit. So there are only single bit, so that will be created bucket of 2 power 0. 2 power 0 is representing the 1, so there should be a bucket of size 1. So now you can see that in this diagram, author had created a bucket size of 1, and the one which is incoming bit stream will be filled inside the one. Now the next rule is that if there is a same size of bucket, you can merge all those bits into a one bucket. So you can find out that there is a two buckets of the same size of one. So this bucket is representing by 2 power 0, and this bucket is also representing by 2 power 0. So you can merge these bucket and create a single bucket of information. So when we are merging this bucket, you can find out that 2 power 0 and 2 power 0 both are of size 1 and 1. Now we have merged this bucket, and whatever the 0 comes within that bit, that will be taken as it is. So we'll create a new information here, that is a 1001. Earlier it was constituted of two bucket, now it is constituted of single bucket. Now the bucket size will be increases because there are two ones, so we will create another bucket of 2 power 1. Now, by this way, we have done it for single one bit information. Now we'll do it for the next two bit of information incoming data stream. So in this way, you can find out that we have taken all the ones here. Now, what happens here? You can find out that when we go from left to right, we'll find out that there are two buckets of same size. So this rule will again apply to the in other buckets. So we'll take a 2 power 1 bucket and 2 power 1 bucket. So now it is represented by the two bucket size and two bucket size. So if they are the same size, we are going to merge them. So when we merge them, we are going to get a bucket size of 4, which will be represented by 11000101. So we have created a bucket size of 2 power 2, and we are merging those. Now, if we'll move toward the leftmost, then we'll find out that we are having the same bucket size. Now we'll again merge these bucket size. So by this way, you can merge all the bucket information, and you will do the process until there is a no bucket of same size is there. And second condition is that if you go from the right to we go from the left to right, then the bucket size should be in a decreasing order. There should not be increasing order of the bucket size when we are going from left to right. Okay. Now, by in this way, we can find out the number of bucket and all the respective of their sizes, and by this way, we can easily calculate the number of one in the given data stream of window length n. So by this way, you can calculate that n is equal to 24. So there are 16 1 which is less than 24 if greater than equal to 1, and so on. Okay. So now let us go to the algorithmic step. Yeah. Rules for forming the bucket. So these rules are written here. We have already discussed this rule. Just let us go through these rules. The right side of the bucket should always start with 1. It means when we are creating a bucket, a right size of a bucket. So whatever the bucket, whether it is size of 2 power 2, 2 power 1 or 2 power 0, right side of bit will be must be always 1, must be always 1. So it should be started with the 1 always. If it is start with the 0, it will be neglected. So whenever you're creating a bucket, you must ensure that whatever the right bit, that should be 1. Every bucket should have at least one, else no bucket can be formed. So we can find out that we have created a bucket size of 1 represented by 2 power 0, and the element inside the bucket is 1. So if there is a no one, there should not be any bucket. You can see here that if there is a 2 0 or single 0 or 3 0, we are not creating any bucket for that. So the second rule is that we have to create a bucket which have at least one 1. All buckets should be in power of 2. So whenever you are creating a bucket, the bucket size must be in the power of 2. So it can take any value 2 power I, where I can be any value 0 to n, but n must be less than the length of the window n, because whatever the window length size is there, your n always less than compared to n. Bucket cannot decrease in size as we move to the left. So when we are going from left to right, and bucket size cannot be decreased. So you can find out that here when we are moving from left to right, you can find out the bucket size is in an increasing order. And when we are moving in reverse order, then you can find out the bucket size is in a right mode, in a decreasing order, and so on. So it is a DGM algorithm. So that is uh, a simple explanation of DGM algorithm. So if you are getting the question size of how many ones are there in the last 20 bits, so you can create a 20 bit of whatever the input data stream is there. You can apply the DGM algorithm. You can create a bucket size of that, and based on the bucket size, you can calculate the number of ones. Okay, so that is was the DGM algorithm. Do you have any doubt or question? Any student? You can also use the chat box. Do you have any question or doubt? Okay, so I will assume that it is clear to everyone. If you have any question or doubt, you can also consult me after the session. We can take a separate session, or you can drop me an email, or you can also contact me on my WhatsApp number. Okay. Now we'll move toward the next topic, that is a decaying window algorithm. So why the decaying window algorithm is given there? It is designed to identify the most popular element. So, certain times you want to find out the most popular categories in a data stream. You want to find out the most popular songs, most popular videos from the YouTube at real time. You want to find out the most popular tweets from Twitter in a real time, because as a data analytics of data stream, you can find out, suppose certain videos are in a trending moment, so you will find out that particular video is in trending moments. You can optimize your resources to provide a better services to the users, because it happens, suppose a single video is, if it is fetching a lot of users, so what will happen, it will overload the system, so your overall system can performance can be degraded. Users will get a bad quality services from your online streaming. So find out these type of element is very necessary. Sometimes you want to find out some random spike or spam request that might have create performance degradation issues. So for decaying window algorithm can be used to find out those type of random spike and spam request. Now, let us go to the step by step to identify the most popular element trending, in other words, in an incoming data stream. So, we'll use a decaying window algorithm. It will track the most recurring element in the incoming data stream. So, recurring element is representing here the element which is occurring, coming again and again. So, which are requesting by user again and again and again. Discounts in a random score spike or spam request that might have boosted an element frequency. So earlier we have discussed about the estimating the moments of a data stream. So why do we estimate the moment of data stream? Because we find out that which item is being requested by user most, so that we can take some necessary arrangement for that. Here, when we are dealing with the decaying window algorithm, we'll discount any element which having more access by the user if they are represented as a spike or a spam request. So we can discount that, so that we are going to get a better estimation of frequency movement. Now, next. To study more about the decaying window algorithm, you can refer this blog, and this blog is written by the Nitin Bhojwani, and he has discussed a very good explanation of decaying window algorithm. So, in a decaying window algorithm, we'll assign a score or weight to every element of the incoming data stream. So as soon as we are receiving element from a data stream, we assign a score of weight to every element of the data stream. In the next step, we calculate the aggregated sum for each distinct element by adding all the weight assigned to that element. Now, whatever the score or weight we have assigned to every element, now at the end of the data stream, at the end of our window length, we calculate the aggregated sum. We aggregate all the distinct element and add their aggregated sum and assign to the particular element. So by this way, we can find out the highest total score is for every distinct element, and we can take that highest total score for any distinct element is treated as a trending or the most popular element. So simple logic that whatever the information is coming to us, we'll assign a score or weight to that. Now we'll calculate the aggregate weight after the window length or after sample size, and we'll find out the highest total score, and we'll treat it as a trending or most popular element within the data. Now, there are certain situations. Suppose if we are having a kind of situation, we are getting a random spike or a spam request. So maybe your spam request for any certain kinds of videos or certain kind of music will make that videos or music as a more popular, and it will be in a trending. one. But we have to discount such kind of things. So we have to find out how to find those elements, how to discount those uh, element and so on. No, now let us see further. So to avoid such kind of situation, we assign more weight to the newer element, and so that whatever the new element that is requested by the user in a real time will have a more weightage. It is common sense that if you are having a new video will be uploaded or posted on the YouTube, a new tweet has been posted on the Twitter, you can find out that these videos are tweet or these music information should have a more weightage because they are having a more uh, possibility to be preferred by the user compared to the older elements or older articles. So we have to reduce weight of all existing element by a constant factor a and assign the new element with a specific weight. So if we have to make sure we have to do two things. First, we have to assign more weight to the newer element, and we have to reduce the weight of the all the existing element. So we have to do both things because it happens because whatever the existing element at the time decay, it preferences among the user will be decreases. So when a certain video is posted on a time after a certain time it will be out of users preferences, and users are not very keen to watch that videos. They are always expecting a new video, a new audio, a new information to them. So, in a decaying value algorithm, aggregated sum of the decaying exponential weight can be calculated using the following formula. So here I is representing your incoming element inside the data stream, where t is your time stamp. So you can find out that t minus I is representing the element at a current time. Here C is a small constant where you can take any order from 10 power minus 10 power 9 minus 9. It depends on you on the problem also. So you C can be take any value in the order of 10 power minus 6 or 10 power 9 minus 9. Here T plus 1 is represented by the new element at that particular time. In a data stream consisting of various elements, maintain a separate sum of each distinct element. So we have to find out first distinct element within the data stream, and then we have to find out the aggregated weight of particular distinct element and maintain a separate record of that particular aggregated sum. Now, for every incoming element, multiply the sum of all existing element by a value of 1 minus c. So when we are receiving a new element, we'll multiply 1 minus c to the all existing element to their aggregated sum, and where c is represented by any constant in the order of 10 power minus or 10 power minus 6 or 10 power minus 9, and the weight of the incoming element to its corresponding aggregated sum. A threshold can also be designed to ignore the element of weight lesser than threshold. So suppose you want to ignore certain kinds of information which is having a low value, low score value or low weightage values. So you can design your threshold value. Finally, the element with the highest aggregated score is listed as the most popular element. So after applying this approach, whatever the highest aggregated score is coming out of it, for any distinct element, we take that distinct element as the most popular element. Now let us go with some example here. So example is a sequence of Twitter tags. So these are the some Twitter tags: FIFA, IPL, FIFA, IPL, IPL, and IPL, FIFA. These are the information which is coming to you in your data stream. Now we'll assume each element in sequence has a weight equal to 1 and C equal to zero point 0.1. So we have taken a C as a zero point 0.1 and weight as a 1. No. Aggregated sum of each tag in the end of above stream will be calculated. So now we'll calculate the aggregated sum for each tag on the given data stream. Now there are, you can see there are only two tags two distinct tags, FIFA and IPL. So we'll calculate the aggregated sum of only for the FIFA and IPL. So there are no third distinct element here. So we'll calculate two aggregated sum for two tags. One is FIFA, one is IPL. Okay, so now we'll calculate the tag for FIFA. So it will be calculated as when we are taking a FIFA. So it is the same element. We'll start with the one. Then we multiply each and every element to the 1 minus e power I. So we have taken point 1. So we'll multiply 1 minus point 1. So it will be evaluated is equal to 0.9. Now it will be an existing element. Now our next element is IPL. So we'll again take the existing element with and we'll multiply with the 1 minus point 0.1. Now we'll add the plus 0 because we are adding the 0 because current tag is different than IFL. Now the IPL tag will be there. We will evaluate all the incoming element by this approach, and the last we are getting a value of FIFA 2.135. Now same approach, we calculate the IPL, and here the slight difference. We are taking FIFA existing element as the one because current tag is different than IPL. So by this way, we'll calculate the aggregated score for FIFA, that is a 2.135, and the aggregated score for the IPL, that is a 3.7264. So you can find out that IPL has a more trending score compared to FIFA. So so the IPL is a trending than FIFA. So if you can see that here in a incoming sequence, that IPL is a 4 times compared to the FIFA. So it is seems to that IPL is more requested by the user. So it is a more trending team compared to the FIFA. But taking will the window algorithm is the approach to identify finding a score for any given stream and find out the score. What is the advantage of decaying window algorithm? You can find out the certain spike or spam data, and you can remove those spike or spam data from your data stream. A new element is given more weight by this mechanism to achieve right trending. So this was the decaying window algorithm. So that's all for the today's session. If you have any question and answer, you can post in the chat box. If you want to repeat certain context, we can definitely discuss with you. And I will open this session for another 10 minutes for question and answer. Okay, thank you for joining the session. I'm stopping the recording.